Welcome to Maths with EJD. In this video, I start with non-homogeneous second order ordinary differential equations and methods of solution for them. So, um, non-homogeneous, second, non-homogeneous second order. Okay, let me do it this way. ODEs, okay? So we're going to be looking at three methods, one at a time. In this video, we'll focus on the first one, which is the method of method of undetermined coefficients. Undetermined coefficients. Then after that, I'll be looking at the operator method. And lastly, we'll be considering method of variation of parameters. So I'll just call that variation of parameters. Variation of parameters. Okay. All right. So let's go for the first one. That is method of undetermined coefficients for solving non-homogeneous second order differential equations. Okay, so like we already know, right? Depending on how we would like to represent it, a a non okay, let me do a kind of overview, right? As usual, a non-homogeneous a non-homogeneous second order differential equation has the form. So you see that the form has been really flexible depending on what we want. Has the form y prime prime plus p of x y prime plus q of x y equals g of x. So this is the form. So I mean you can be flexible with this. So to solve this type of equation, we break the solution into two parts. Break the solution into two parts. Okay. So the first part is the homogeneous part. So we have the first part, which is the homogeneous or complementary solution. Homogeneous or complementary solution. That's the first part. So I like to represent that as YC. Okay. Yeah. So here we solve the corresponding homogeneous equation. So we forget about the non-homogeneous part, right? So of course, the deal here is that this g of x, in this case of non-homogeneous, g of x is surely not equal to 0, okay? That's what makes it non-homogeneous. So solve the corresponding homogeneous equation. So, and that is y prime prime plus p of x y prime plus q of x y equals 0. So this is the homogeneous part now. So we solve this using the method of characteristic equations, and then we get, we have those possible solutions we can get depending on the roots of the characteristic equation. So that's the homogeneous part. Then the second part, that's the particular solution part, particular solution. So, yeah, particular solution. So for the particular solution part, right, you can use a method. You can use a method like undetermined coefficients, undetermined coefficients, the operator, or variation of parameters, variation of parameters to find a particular solution, a particular solution So the particular solution, you can represent that as yp of x. So the one up there is a complementary solution, which is yc of x. Where is that now? Yeah, yc of x, like this. Okay. So that satisfies the particular solution that satisfies the non-homogeneous equation, the non-homogeneous equation. Okay. All right. So the general solution is y of x equals yc of x plus yp of x. So that's the general solution is the complementary solution plus the particular solution, basically. All right. So we move on to method of undetermined coefficients, which is the focus here. Method of undetermined coefficients. Okay. Method of undetermined coefficients. So the method of undetermined coefficients is used to find a particular solution, for non-homogeneous, second order linear differential equations. When the non-homogeneous term, g of x is of specific form, such as a polynomial. So it could actually be a polynomial. It could be exponential function. It could be sine or cosine. So what I would do in this video is to show all the possibilities, all these three possibilities. So let's look at some steps. Steps for undetermined coefficients. Steps for undetermined coefficients. Okay. So the first step is to solve the homogeneous equation. Solve the homogeneous equation to find yc of x as the first thing. Step 2, you guess a form. Guess a form for yp of x. So that's the representation for the particular solution. And that will be based on the form of g of x. So this will be explained better with each example we take. Number 3, you can now determine the undetermined coefficient. So you're going to have some undetermined coefficients in step two above. Determine the undetermined coefficients. That's why it is called the method of undetermined coefficients. So you do that by substituting yp of x into the original non-homogeneous equation, okay, and solving for the unknowns. Okay. All right, so with that done, right, let's take the examples one after the other and see how they go. All right, let me go black with this and then say this can be this, or even this now. Okay. So example 1, Example 1. So the question is solve y prime prime minus 3y prime plus 2y equals e raised to power x. So the non-homogeneous part is e raised to power x. That's exponential in nature. So what we are going to do is first, so we have step 1, okay, find the complementary solution yc of x. That's the first thing. And the way to do that is we get from the homogeneous part. So we say from y prime prime minus 3y prime plus 2y equals 0. You see, this is the homogeneous part because we have left this aside now. So from here, we can get the characteristic equation r squared minus 3r plus 2 equals 0. And if that is the case, we can simply say r minus 1 into r minus 2 equals 0. That means r1 is 1 and r2 is 2 because these are distinct solutions now. So we can say, therefore, yc of x is equal to C1 e raised power 1. You know, we are talking about y of x. C1 e raised, C1 1 raised power 1x, that's C1 e raised power x, then plus C2 e raised power 2x. Okay, that's the complementary solution. Done. So the next thing is step 2. So step 2, okay, we want to find yp of x. Okay, we want to find yp of x. So since g of x, that's the right hand side, since g of x is equal to e raised power x, so we can guess the form, yp of x is equal to a undetermined coefficient a raised power ex. Now, this is what we should do normally. But guess what? When you come here already, there's already a term that has ex. So, and since C1 is a constant and a is also a constant, so that is going to be an issue. Um, so we can say since yc of x is already C1 e raised power x plus C2 e raised power 2x, and the particular solution now has a term that looks like what we already have there. So we modify. So if you have something like that, so we modify yp of x to be, you now multiply that by x. So you have ax e raised power x. So this is a modification that we can use now to avoid repeating the same solution, because the solution would automatically be the same if you use that up there. So I can now say from yp of x equals ax e raised power x now, okay? So you can then, so if you look at the original expression, we need the second derivative, we need the first derivative, we need the ordinary y. So this is like the ordinary y now, yp of x, ax e raised power x. So we now need yp prime of x, and that is, so this is this is like product rule, right? So if you differentiate x at first, so you have e raised power x. If you differentiate this x, then if you differentiate e raised power x, then you're going to just get you're going to get ax. When you differentiate e raised power x, you get e raised power x again. So that's what we have for yp prime prime. Then when we have for yp prime prime of x now, when we come here, so differentiate e raised power x here, you have just your a e raised power x, then plus this one gives us what happened before. So differentiate x, you get a e raised power x again, and then differentiate e raised power x, you get ax e raised power x, function of a function. So that yp prime prime of x is actually yp prime prime of x is equal to 2a e raised power x plus ax e raised power x. Okay, so what we are going to do now, we are going to substitute this one, maybe to make for effect, we want to substitute this, and this into the original expression, which is y prime prime minus 3y prime plus 2y equals 0. Okay, so now say, so for y prime prime, so we now say prime prime minus 3y p prime. So that yp now plus 2yp is equal to e raised power x. Okay, this is what we now do. So we substitute all of that into it. So yp prime here is, so we have 2a e raised power x plus ax e raised power x, then minus 3 into yp prime prime, yp prime prime, yp prime rather, that's a e raised power x plus, that's a e raised power x plus ax e raised power x. Lastly, we have 2yp. So 2yp, so we have plus 2y. Yp is simply ax ex. So that's ax e raised power x. And all of this now is equal to e raised power x. All right. So we can expand, we can open up everything, and we have so we have 2a e raised power x plus ax e raised power x minus 3a e raised power x minus 3ax e raised power x plus 2ax e raised power x is equal to e raised power x. Now, if you look at everything now, so can we collect like terms? This is 2a raised e raised power x. This is 3a e raised power x, right? So that means minus, we have minus, so that would give us minus a e raised power x. And here we have ax e raised power x minus 3a e raised power x plus 2a e raised power x. Okay, interestingly, 2a plus a is 3a. So those will actually cancel out, thankfully, and this is equal to e raised power x. Interestingly, if you divide through by e raised power x, you have minus a equals 1. So that simply tells us that a is equal to 1. So we have our a. So the coefficient has been determined. So that means that the coefficient of a that we have up here, this a here is simply a. So we can now say, therefore, the particular solution, okay, is yp of x equals x e raised power x. Okay, that is our particular solution. Don't forget, we have got yc of x already, so we now have to add the two together. So we can now say overall y of x, right? Overall y of x, which is the same thing as yc of x plus yp of x, will now be y of x equals yc of x is c1 e raised power x plus c2 e raised power 2x plus not yp, right? Our yp is okay, this is minus, right? This should be minus because a is minus 1. Don't forget, this a should be minus 1, not just 1. So minus a is 1, so a is minus 1. So that should be minus x. Okay, let me just do this. Minus x e raised power x. So we can then tidy all of this up. And then we have y of x equals c1 e raised power x minus x e raised power x plus c2 e raised power x. So that is yx is equal to c1 minus x e raised power x plus c2 e raised power x. So this is the solution in that situation. So that's one case. Now let's look at example 2. This one is for exponential form. So let's look at example 2 that is of another form, right? So we say example 2, we want to solve y prime prime plus 6y prime plus 9y equals 3x squared minus 2x plus 1. Okay, that's what we have there now. So okay, so of course, for yc of x, that's the complementary solution, we see that this is y prime prime plus 6y prime plus 9. So that will be r squared plus 6r plus 9 equals 0. That's the complementary part. Okay, so that means we just have r plus 3 squared equals 0. And if you remember what we said the other time, for complementary solutions like this, I mean, for solutions like this that are repeated, so you just see that r1 is minus 3, r2 is also minus 3. So what that simply tells us is that we can say therefore yc of x is equal to, that'll be c1 e raised by minus 3x plus, instead of saying c2 e raised by minus 3x, we now say c2x e raised by minus 3x because of the repeated roots. So that means that yc of x is equal to c1 plus c2x e raised by minus 3x. Okay, that's taken care of. Then we can now go to the particular solution part now. So for yp of x now, so we can guess, because from the original expression you have a coefficient. Okay, we can guess from g of x, which is equal to 3x squared minus 2x plus 1, we can get from here that yp of x should be something like, differentiate that. So you get undetermined coefficient a with the x squared plus undetermined coefficient b with x plus a constant c to align with 1. Okay, so we have yp of x. So this is our guess in this case. So that means we need other parts like yp prime of x. So when we differentiate with respect to x, we have 2ax. Then differentiate bx, we get b. So we also need yp prime prime of x, and that will just be 2a. Okay, so we are going to plug all of this now. We can now say, for the original expression, for y prime prime plus 6y prime plus 9y, okay, equals 3x squared minus 2x plus 1. So we can plug all of that into it. So y prime prime is simply 2a. So we have 2a plus 6 into y prime. Y prime is 2ax plus b. That's 2ax plus b. Then plus 9. 9 is ax squared plus bx plus c, and all of that is equal to 3x squared minus 2x plus 1. So to make things right, let's expand. We have 2a plus 12ax plus 6b plus 9ax squared plus 9bx plus 9c is equal to 3x squared minus 2x plus 1. So what we are going to do now is to collect terms like similar terms. So for x squared now, we have 9ax squared and 3x squared. Those are the only similar things. So then we can just say that 9a is equal to 3. Okay? We don't have any other x squared anywhere. So that simply implies that a is equal to 3 over 9. That means that a is equal to 1 over 3. So easy peasy, we got our a. Then let's look at other ones. Imagine if we look at x. So we have 12ax, we have 9bx, and that is equal to minus 2x. So that means that 12, so this is for x squared now, okay? So for x now, for x, it means we have 12a, okay, plus 9b, 12a plus 9b is equal to, and the x on the other side is minus 2. So we can compare them like that, all right? So that means that, thankfully, we have a already. So we have 12, and a is 1 over 3 plus 9b equals minus 2, okay? That's minus 2. So this is 4 plus 9b equals minus 2. So that means that 9b is equal to minus 6. That's minus 2 minus 4. So b is minus 6 over 9. So that implies that b is equal to minus 2 over 3. Thankfully, b is sorted. Okay. So can we go on again and say and look for the last thing? Constant now. We have 2a, 6b, things that don't have x or anything. And that is equal to 1 on this side. So we have 2a plus 6b, right? Is that, yeah, that's 2a. So we have 2a plus 6b. So we now say for constant k now, that's 2a plus 6b, all right, plus 9c is equal to 1 on the right-hand side, all being constant. So we have a already, thankfully, that's 1 over 3. So that is 2 into 1 over 3 plus 6 into minus 2 over 3, that's for b, plus 9c is equal to 1, okay? So this is 2 over 3 minus 3 here is 1, 3 here is 2. So that's minus 4 over 1, okay, plus 9c is equal to 1. Well, I like to just make everything go, remove fraction. So I can multiply 3 by 3. So I have 2 minus 12 plus 27c equals 3. Okay, so that means 27c is equal to 3 minus 2 plus 12. Okay, 3 minus 2 plus 12. So that's 27c equals 13. So again, c is equal to 13 over 27. Okay, so we have a, b, c. All the undetermined coefficients have now been determined. We can now say, therefore, the yp of x is equal to ax squared plus bx plus c is simply yp of x equals a is 1 over 3 x squared, b is minus 2 over 3. So minus 2 over 3x plus 13 over 27. So that is our particular solution. So we can then talk about the general solution. So the general solution, y of x is equal to yc of x is equal to yc of x plus yp of x. So yc of x again now. So we have y of x is equal to yc of x is c1 plus c2x e raised to power minus 3x, okay, plus yp of x that we just got, that is 1 over 3x squared minus 2 over 3x plus 13 over 27. And that is the general solution for that polynomial non-homogeneous part. Okay, so let's do one that involves that involves trigonometry. Okay. Okay, let me go this way now. Let me go for this and then okay. Yeah. So example 3. Example 3. So for example 3 now we have to solve y prime prime plus 2y equals cos x equals cos x. So how do we go? So here, first of all, we say for yc of x, that's the complementary solution. Automatically, we have from y prime prime plus 2y equals 0. We have the characteristic equation r squared plus 2 equals 0. That means that r is simply uh plus or minus I root 2. Okay, so that is automatically that is what is that called now? That is a complex number, and that means that yc will be oscillatory. So we can say therefore yc of x is equal to c1 cos root 2x plus c2 sine root 2x, and that goes like that. So that's yc, and we go for yp. Okay, so for yp of x, we can guess from, you see, the right hand side is g of x, from g of x, which is equal to cos x. Now what will make you guess right is, you have yp of x to be, so when you differentiate cos x, you get sine x. Okay, so you can have the undetermined coefficient a cos x plus, when you differentiate cos x, you get sine x, so that you now have b sine x again. If you differentiate sine x, you get back to cos x. So this is a good guess. Okay, this is a perfect guess because it's either sine or cos, so you can stop here. So we now need yp prime of x to be, differentiate this now, you get minus a sine x. Differentiate this, you get plus b cos x. That's yp prime. Then if you go for yp prime prime of x equals, differentiate this, you get minus a cos x, then minus b sine x. That's how that goes. So you can now go back to the to that expression, the original one. So from y prime prime plus 2y equals cos x, what do we get? So yeah, so you can say yp prime prime, then 2yp. Okay, so that means we have yp prime is minus a cos x minus b sine x. That's for yp prime. Then 2 into the original yp, that is a cos x plus b sine x. Okay, and that is equal to cos x there. So we can tidy things up. So we have minus a cos x minus b sine x, okay, plus 2a cos x plus 2b sine x equals cos x. Okay, so 2a cos x minus 2a cos x, right? Okay, 2a cos x minus 2a cos x. Okay, then that will simply be a cos x, and 2b sine x minus b sine x, that'll be plus b sine x again, and all of that is equal to cos x. So you can compare things now. So if you want to compare, you can say for cos x, right? For cos x, if you compare both sides for cos x, so on this side you have a, on the other side you have 1. So interestingly, a is simply just 1. Okay, so for sine x, on the left hand side, the coefficient of sine x is b, and on the right hand side there's no sine x on the right hand side, so just be 0. So simply b is 0, a is 1. So if that is the case, now we can then go back to the original expression. So we now say, so for yp of x, okay, which is equal to a cos x plus b sine x, right? So a is 1 and b is 0. So we have yp of x is equal to 1 cos x, that's simply cos x, 0 sine x. So this is 1 cos x plus 0 sine x, okay? So that simply tells us that yp of x is equal to cos x. So our particular solution is yp equals cos x. So we can then conclude and say, okay, so the general solution, is y of x equals yc of x plus yp of x. So that means that y of x is equal to c1 cos root 2x plus c2 sine root 2x, then plus cos x. So that is the general solution in this situation. So with that, we come to the end of this very interesting part. So before we go, let's see if we can have some practice questions. Practice questions to try our hands on. Okay, practice. So just to solve the following, Okay, 1, y prime prime minus 4y prime plus 4y equals e raised by 2x. That's 1. 2, y prime prime plus 5y prime plus 6y equals 3x squared minus 4x plus 2. Number 3, y prime prime plus 2y equals x e raised power x. Okay. Number 4, y prime prime plus 2y prime plus 5y equals cos 2x. Okay. Let me add one more. 5, y prime prime minus 2y prime, okay, minus 3y equals e raised power 3x. All right, so let me see your answers in the comment section, either on YouTube or on Facebook. And of course, let me also see in the comment section if you have a topic you'd like me to teach you, a problem you'd like me to solve. Let me also know how helpful these videos are for you. Then if you have not subscribed, please go ahead and subscribe, because I still have more coming. I still have 2 methods under this and many more coming, right? So subscribe and hit the notification bell so you can always get alerted each time a new video is released. Of course, also like and share so that more people can have access to this great content. Like, come your way again, keep doing maths right. Bye.